and he runs into a neighborhood, and the cops lose him. Okay, and so the cops want to set a boundary, and they're going to search for this bad guy. Right? If they want to be really confident that their search zone includes the bad guy, should they make their search zone big or small? If they want to be very confident that they get him, they have to make the search zone very big, okay? But a big search zone is time-consuming and expensive and whatnot. It requires a lot of manpower. So they have to make a decision. They can trade off the confidence that their search zone has the bad guy versus how big of a search zone to have. Okay? And so, you know, if you make a confidence interval about, you know, something, it could be like from 85 to 100, 105. And maybe that's good enough for you. Okay? Or you say, well, I actually want something a little bit more precise. Well, yeah, there's a trade-off. You can have a more precise confidence interval at the expense of being less confident about it. Okay? Just like when the police are searching for a fugitive or for a criminal, they can shrink the search zone at the expense of, you know, maybe their search zone was too small and they're missing the bad guy. I think that was the case with like the Boston bomber. They had a search zone and they searched everywhere, but the guy was just outside of the search zone, right? He was like hiding in a boat or something. Yeah.
What is analogous to the search zone?
So the search zone is analogous to how big the interval is, how wide, you know. It's 95.6 plus or minus this what we call a margin of error, okay? So we can have a large margin of error, which most people don't want a large margin of error, okay? I could say, you know, what is, you know, President Obama's approval rating right now? And I could say, oh, it's 50% plus or minus 50%, okay? Or 50% plus or minus 49%, okay? And that's a huge margin of error, and it's not a very meaningful thing, okay? I'm very confident that it's between 0 and 100%, okay? Or actually, I'm 100% confident that it's between 0 and 100%. And so, you know, and we could be 100% confident about anything by saying it's between negative infinity and positive infinity, okay? But that's too wide for it to be useful, okay? If you're willing to give up some confidence, you can have a smaller interval or smaller margin of error, and that's what we have. So changing the level of confidence actually only affects your choice of T-star, and you can see that as you increase or decrease confidence within a row, that those numbers get bigger or smaller. All right, so what does it mean to be 95% confident or 90% confident? This idea of 95% confidence comes from our understanding of the sampling distribution. Okay. The way we're making this confidence interval, taking the mean of the sampling distribution, adding or subtracting this margin of error, basically it's saying, you know, we understand, you know, like the behaviors of the dog, we understand the behavior of Y bar. And so that 95% of the time, when we take a random sample, that Y bar should be within this margin of error of the population mean, okay? And so if you were to repeatedly take many, many samples, okay, you wouldn't do this in real life, but if you were to take, let's say, 1,000 samples, and each of them you'd make a 95% confidence interval, some of those confidence intervals will have the population mean in between the two ends, like this one. The population mean we know is 100, and 100 is in between 85.79 and 105.41. But some of the confidence intervals you make will be wrong, okay? And that's just a result of the random sampling, okay? Because of random sampling, you ended up with a confidence interval that maybe went from 81 to 99, okay? 81 to 99 doesn't have the actual population mean of 100, okay? It just missed it in that case. And And if you follow the methods for making a 95% confidence interval, your confidence interval will miss the population mean about 5% of the time. Okay? It sounds kind of like this, but this is making a statement about mu. When we're saying 95% confident, we're talking about what happens with our interval. Okay? So when we say, I'll write this up on the board. Okay. When making a confidence interval, the random part is in the random sampling. Okay, that's the only random part of your confidence interval. Okay, so there's randomness in the random sampling. Okay. And so when we say we are 95% confident, that mu is within our interval. That means if we repeatedly make many 95% confidence intervals, we would expect 95% of those intervals to actually quote, capture mu, and about 5% to quote miss.
So if you take this sample 1,000 times,
Mhm.
a sample of 100,
Yeah.
let's say sample of 1,000 times.
Okay.
So 950 of those times mu will fall within.
Yeah, we expect about 950 of those confidence intervals that you make, because you're making 1,000 of them, one for each sample. We're expecting about 950 of those intervals to be, quote, correct, in that it captures the actual mu.
Okay.
And about 50 of them will be wrong, okay? And it's not that you did anything wrong, it's just that because of the nature of random sampling, that random sample just happened to be weird enough that you ended up with a sample that led you astray, okay? You know, it's like maybe you go traveling to Seattle, okay? And maybe you happen to get lucky that when you landed in Seattle, it was a clear and beautiful day. And then you fly away and you leave Seattle, and people ask you, what was your impression of Seattle? And you say, oh, it's beautiful, blah, 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 you know? And it is beautiful, okay? But that may not be a true reflection of what's happening, because just by coincidence, you happen to go on a day that happened to be clear and sunny and bright, okay? Whereas most of the time, the weather's a little dreary, right? You don't know, when you take a random sample, you don't know if you're getting one of the, quote, regular looking samples, or one of those extremely weird ones that are off on the edge, okay? When you make a confidence interval, you have no idea which one you end up with, okay? All you're counting on, you're just banking on the fact that most of the time the samples will be regular looking. And so that when you make a confidence interval, It should capture the true value of mu. Is it possible that you get an unusual sample? Yeah, and you would have no idea, okay? You have no idea until other people say, wait a second, that's weird, all right? That's weird that you think Seattle has beautiful weather, okay? You don't know that until, other information comes in. So that's what happens when we make confidence intervals. But this is our first application of our understanding of sampling distributions. And that's confidence intervals. How are we doing here? Okay, I think, well, are there any questions? Yes?
Sampling distribution, the sigma over square root of n is when we understand something about the population already.
Yeah. If you were using, I deleted it, or erased it. Sigma over the square root of n can only be used if you know sigma, which is the standard deviation of the population. There might be a rare circumstance where you don't know the mean, but you know the standard deviation of the population. But generally, 99.9% of the time, that's not the case. If you don't know the mean of the population, you're probably not going to know the standard deviation of the population.
We just have a confidence interval for a single sample. We can also have a confidence interval for...
Yeah, actually, right now we've only learned, next week we'll cover confidence intervals for a difference between samples. Okay, but today we're just taking one sample and we're making a confidence interval based on that sample about the population mean mu.
I'm asking because I feel like as we go chapter by chapter, it's kind of easy to see where the differences are in the questions you're asking, but when it comes time to the midterm, we're going to get all these different questions,
Yeah.
different chapters.
Yeah.
It'd be hard to recognize what chapter we're talking about.
That's true.
Is that part of the challenge, or?
That is part of the challenge. Next week I'll try to spend a little bit of time just reviewing some of the concepts and maybe helping differentiate between what's going on.
They start to look the same.
But yeah, a lot of things will look similar. There's a similar theme throughout a lot of the stuff we're doing. Okay, so yeah. But it's a valid concern. So okay, well if that's it, you guys are dismissed. Thank you very much for the cough drops on the water. I don't know, it's kind of embarrassing, but it happens. So.